In this video, I'm going to teach you homogeneous differential equation. In our previous classes, we talked about the first order, exact, order degree, and other parts of differential equation. Joining me in this video, I'm going to take you through homogeneous differential equation. I've already taught you how to determine if a function is homogeneous or not. So the core of this video is simply to go straight away to teach you how to solve homogeneous differential equation. A recap: every homogeneous differential equation should satisfy this, that is f of tx, ty should be equal to f of x, y. When this condition is satisfied, then it means that our differential equation is homogeneous. Then we can go ahead to solve it. To solve all homogeneous equation, we make a substitution y is equal to vx. Once you make this substitution, you are supposed to divide and find the y. So let's differentiate this function we have here, this equation. So I'm going to have the y over the x will be equal to, this is implicit, so I'm going to have the v over the x, then this one has been differentiated, but I'll maintain this. Now this will be differentiated, which will be what? 1 multiplying v. Once I get this, I'll multiply through by the x, so the x by the y over the x is equal to the v multiplying x all over the x times the x plus v dx. Now this can easily cancel this will cancel this, then I'll be left with the y is equal to x dv plus v dx. So this is the most important part of homogeneous differential equation. So we'll be making this substitution in order for us to solve a homogeneous differential equation. I have my first problem to be x minus y dx plus x dy is equal to 0. So first of all, let's prove that this equation is homogeneous. You only have to substitute x and y with tx and ty and ty. So wherever you see x, you put tx, wherever you see y, you put ty. So I'm going to get tx minus ty dx plus tx dy. Now let's see, I can factorize my t out here. I'll get x minus what? Y. I can factorize my t out, tx. Whenever you can factorize your t back to get your main function, this one is going to be a quotient for this t to cancel out. But since it is in the differential form, we only have to make sure that the t can be factorized out of it, leaving the functions back again. Hence, this differential equation is homogeneous. Let's move ahead to solve this. So to solve this differential equation, this is the equation we have. We are going to make the substitution, the y is equal to v dx plus x dv. As we solved here, x dv plus v dx. So wherever you see y, you put what? Vx, because y equals vx. So I'm going to get x minus vx multiplying the x plus my x, then this dy here, I'll replace it with what? V dx plus x dv. At this point, I'll multiply through and I'm getting x dx minus vx dx plus xv dx plus s squared dv. Everything here equals 0. Hence v dx, this is negative, this is positive. It can cancel out and I'll be left with x dx plus s squared dv equals 0. Once you break down homogeneous equation, it is expected for you to get a separable differential equation. At this point, I'm to separate the x and the y. So this is what I'm going to get. S squared dv will be equal to negative x dx. I'll bring so this is the dv, so I'll make sure that I let it stand there alone. So this will cancel this, and I'm going to get dv is equal to x will go into itself 1 and go here x, so negative dx on x. At this point, it's separable, so you only integrate both sides. So integral dv equals integral negative dx on x. Once you have this, it's equal to, when you integrate dv, you are going to get v plus a constant. So let's say plus k is equal to this place. It's going to give us negative ln x. So plus c. At this point, I'll combine the two constants and I'll get only one constant. So v will be equal to negative ln x plus c. Now, let's see. We are going to solve this equation. You know that our v here, we got that from y. We made the substitution y equals vx. So once you have this v, you can easily make the subject so that we get v is equal to y over x from this side. So this becomes y over x is equal to negative ln x plus c. So my y is simply equal to negative x ln x plus cx. And that is the solution for our homogeneous differential equation. Let me show you the second example. So example 2. I have x minus 2y dx plus x dy equals 0. Once you have this, the first thing to do is to make your substitution. Dy is equal to v dx plus x dv. But this substitution comes from y equals vx. So once you see y, you put vx. So I'm going to have x minus 2 vx dx plus here x open bracket, my dy becomes v dx plus x dv. Expanding this, I'm going to get x dx minus 2 dx vx plus here I'm going to get xv dx plus s squared dv equals 0. I left equals 0. So now I have vx, 2vx dx, then this is vx dx. So you can see there will be x dx, this negative 2, this is positive 1, so minus x v dx plus s squared dv equals 0. Once you get this, I can factorize x out, and I'm going to get, when I factorize x out, I'm going to get x out, or let me make it x dx. So when I factorize x dx out, I'll get 1 minus v from this side plus s squared dv equals 0. So at this point, I'm gradually separating what I have. So I'm going to get s squared dv will be equal to negative x dx 1 minus v. I will then divide through by x squared by x squared. So I'm going to get dv equals negative x over x squared dx and 1 minus v. I can then divide through by 1 minus v. This will cancel and I'm going to get dv over 1 minus v is equal to, here will give me negative 1 on x dx. So at this point I will integrate both sides, cos integral negative 1 on x dx. So once I have this expression, I can have here to be what? 1 minus v, so ln 1 minus v will be equal to negative ln x plus c. So let's see. At this point, once we have integrated both sides, we are just to make v the subject. So from here, 1 minus v will be equal to e to the power negative ln x plus c. Hence, my v will be equal to 1 minus the expression e to the power negative ln x plus c. You know v is the same as y on x because 1 minus e to the power negative ln x plus c. But y on x, when you have e to the power negative ln x, is the same as 1 minus e to the power ln 1 out of x multiplying e to the power c. Hence, my y over x will be equal to 1. This place become 1 over x minus 1 over x like this. Then multiplying e to the power c, which is going to give us c. E to the power c will give us c. So y over x will be equal to 1 minus 1 over x c. Then I'll multiply through by what? X. So that I'll get y is equal to x minus what? C. Right. So let's see. So once you have this, our homogeneous differential equation has been solved. This is all I have for you in this video. Please subscribe to this channel for more content like this. Like, then you share.